Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. In this episode, I'm delighted to welcome ARM's Chief Architect, Richard Grisenthwaite, to the show. We'll be chatting about the intersection between security and AI. As artificial intelligence becomes more deeply embedded in our systems, it's not just transforming how we detect and defend against threats, it's also changing the nature of those threats. So what are the new AI-related security threats and attack vectors we should be aware of? How are we countering those new threats? And how can we use AI to do so? Here's my conversation with Richard. Richard, welcome to the show.
Thank you very much, and thank you for having me.
So I'm really excited to kick off this conversation about security. Security is a topic I don't know a great deal about, but I understand there are going to be new things we should be talking about in security as it regards to AI. Maybe let's start with something like this. As AI basically goes everywhere and becomes goes into every single type of system, whether it's IoT all the way up to data centers and everywhere. And as AI basically gets smarter and becomes more autonomous, if we have security problems or security lapses, the potential problems it could cause are going to be much bigger. Maybe let's start with what kind of consequences could we be facing and what is at stake here?
Well, I mean, I think you've portrayed it very accurately there that, we are at the start of this AI revolution, and, we are anticipating that AI will be used in lots of different places and will become more central to our lives. And really, this continues the theme that we've had for many years of more and more of our lives are dependent on computing. And we've seen, along with that dependence, a growing increase in cybercrime and attacks against the system. And of course, what's happening with this increased dependency on computing is two things, one of which is the size of the prize for criminals who want to try and steal something is getting bigger because, more of our lives are there, therefore they can cause more disruption or they can steal more things or whatever else. And the effect of the disruption is greater because they can bring down entire systems, things stop working. So AI is an increase in the amount of compute and the increase of the amount of reliance by humanity on compute. And therefore, computer security, which is actually really important, will become even more important because we'll be more reliant on those computer systems. We'll have, I think, as you alluded to the idea of autonomy within the use of AI, there'll be fewer humans in the loop of what we're doing. And that means that the ability for a criminal to bring something down without it perhaps being noticed, or to cause trouble without it being noticed, or to exfiltrate data without it being noticed will grow. And so I don't think AI fundamentally gives a massively new challenge so much as it just brings a spotlight onto the sheer importance of security of computers, because the computers are now getting more and more important in our lives. And AI is just going to make that even more so. It's a tremendously exciting time, but it means that we have to care about security even more than we have done so far.
I mean, there are all kinds of types of attacks and types of security lapses. You mentioned data theft there. There's also model theft. I mean, if we use AI in a product now, does that necessarily introduce new attack vectors, or what are the new possibilities for attacking and manipulating and stealing AI models too?
Well, I think the stealing of the AI models is a really interesting question. I suppose normally a program, while it takes a lot of effort to generate and so on, we're used to kind of thinking of that as not being an incredibly high value item. But we know that training an AI model is an incredibly expensive operation. The sheer amount of compute being used, there's a lot of energy. There's actually millions of dollars of compute and energy being used to create the models. And some of them are open source, and that's fine, but quite a lot of them are closed source. And that effectively means that if somebody can steal that model, they are stealing something of actually immense value. And it gets even more complicated than that, in as much as for the really big and advanced models, we're seeing that those are regarded as a strategic asset. We're seeing things like governments. I mean, the US government, as part of their export control rules that they brought in January, explicitly called out putting export control rules on exporting the weights of very large models. Now, that clearly shows that governments are regarding those as a strategic asset. And that means that, if somebody is able to steal that, and now we're in the world of nation state actors, because if that's something that governments regard as so important, national enemies could be interested in stealing it. So in many ways, the theft of models is something that really, again, it's about the size of the prize for the criminals. It becomes even more attractive for criminals to go after these things, and therefore it's even more important that our systems are made more robust against what will become increasingly sophisticated attacks, because the prize is bigger.
I mean, he's talking about these really huge models there, and nation states potentially wanting to attack them or steal them. But I think there's also a case for models that are developed by enterprises, because that is their IP. Absolutely. Like, even if it's just something you think it's predictive maintenance, it's this tiny thing, this is their IP still that could be stolen, right?
Correct. And again, this comes back to the more we're using computing, the more we are encapsulating the knowledge that we've got, the processes of a business, and the IP of the business, how it actually makes things. If at the moment a lot of that, or historically, that has been sort of in people's minds, but the more that gets captured and automated using AI, then again, the more, if that gets stolen, company secrets and knowledge can be stolen. So this is all part of the general trend that we're going to be seeing more and more reliance on computing, and therefore we've got to really worry about security. And that's been an area that ARM has been working on for a long time. We've been adding lots of technologies into the ARM architecture to reinforce the security. We recognize the fact that it is a game of cat and mouse. We introduce something and the attackers find ways around it, and we introduce something else to address that, because the sophistication of these attacks is very great. And as I say, the more value that people are able to extract by stealing things, by breaking security, the more incentive they have to be creative to find those ways in.
What about something like data theft? The consequences for stealing people's data, whether it's consumers' data in their smartphone or businesses' data, or there are other use cases too. Data needs to be protected just the same as the model does, right?
Data has always had to be protected, and that's been the focus really of what we've done. I mean, we've introduced things like our realm management extensions, which were put in there to enable confidential compute, and that's been a key part of the story for getting ARM into the cloud, because essentially you want to be able to run your compute on a system, on a cloud provided system, and be able to attest that this is a good platform that I want to be able to run on. And confidential compute, which is just starting to being rolled out over the next couple of years, is a mechanism to allow the user of a computing system to be able to attest that they are running on a trustworthy platform. And that's originally our thought behind that was it was about protecting our data. It was about, my secrets, my bank account details, my company's deep secrets, or government secrets as well. We talk to people at the National Cybersecurity Center, and they care a lot about things like confidential compute, because governments have to be able to put their information on cloud computing as well, want to be able to do that, but need to be able to trust it, because again, they have important secrets. So all of these things have created an interest in that. And so data was kind of where we started out with thinking about confidential compute. But as we talk about the value of the models, the idea of confidential compute is what it does is it protects both the data and the applications from being seen or being silently manipulated by the main operating system or hypervisor, while still giving the main operating system and hypervisor the ability to control the system in the way that it needs to. And that protects the models, and the models are a combination of the architecture of the model, which in some cases is actually a very big proprietarial secret of an AI company, as well as the weights, which are these things that cost so much money to go and create because the training's so big.
Yeah. I'll come back to confidential compute in a second, but could you take us through some of the ways that attackers can use AI to exploit vulnerabilities in hardware? Are we using AI to write malware? Like, how are they using AI against us? This cat and mouse game you're talking about, right?
Well, there's a slightly different angle, but the reality here is that we know that attackers have been able to, that they are very sophisticated people. Cyber criminal. The idea that a cyber criminal is just a youth wearing a hoodie in their bedroom is a complete myth. In reality, these are very well organized, very sophisticated organizations and setups who have used all of the resources they've got to be able to do searching of systems, searching of software, looking for vulnerabilities, creating techniques. And because AI is very good at doing things like scanning and understanding code and so on, then the idea of trying to find latent vulnerabilities that lie in software, for example, using AI to do that is something that I'm absolutely certain must be happening. And we know that, depressingly, and this is a statistic I've been talking about for quite a long time now, but the root cause of many of the software vulnerabilities that exist in the world really come down to things like memory safety errors and things like buffer overflow and use after free. These vulnerabilities in software have been catching programmers out, allowing the criminals in for really the last 50 odd years. I think the first buffer overflow attack was in the 1980s. And what this is because there's a corpus of billions and trillions of lines of code, these things lie latent, and somebody goes, oh, look, there's a buffer, they find a buffer overflow attack. Now, these things kind of get found by happenstance, by sheer good luck in a lot of situations. But if you've got a machine that's able to crawl over code looking for vulnerable sequences, and AI is really good at interpreting a bunch of data, then actually the idea of using AI to essentially probe and look for vulnerabilities, because AI is scalable, you throw more compute at it, it doesn't get tired, it doesn't get bored, it doesn't drop attention. So it's actually relatively straightforward for people to start scaling out, look for vulnerabilities in this code. And given that we know that an awful lot of vulnerabilities have been lying latent for a long time, things like Heartbleed back in the day was there for months before it was found and exploited. And we've discovered through things like the Cherry work that we did that there are a lot of memory safety issues in existing software. Then people will be looking for these, and so AI will provide tools for the cyber criminals, unfortunately.
Unfortunately, yes. From a slightly different angle also, if somebody is using AI just to write software, like people talk about vibe coding now, got a lot of people who don't know much about software that are producing web apps or other different kinds of software. If people use vibe coding, use AI to write software and publish it without fully understanding it or fully knowing what's in it, I mean, that's a massive security risk in itself, right?
Well, there's certainly an element of that, although, I mean, within ARM, we've been talking a lot about how our engineers are using AI for writing code, both for software and writing RTL for hardware. And in both situations, very much the mindset we encourage is the AI is your assistant. It isn't actually taking on the responsibility. You're not abrogating your responsibility for the quality of the code. What it's doing is making you more productive. You as the software or hardware engineer, still need to be responsible for the test plan and for the verification plan, and to be able to think about how do I know that this is a good bit of software or a good bit of hardware. And that goes for security as well. Now, the one thing that AI can do, again, because AI tends to be a bit more tireless than human beings, if you think about it, a lot of coding errors come from, frankly, lapses of attention. That's why things like buffer overflows keep on recurring in software. I didn't think about that particular case. What's nice about AI, and this is the positive side of it, is that the tooling can provide the ability to say, well, this looks like something that might have a buffer overflow. You might want to go look about it. Think about it as an advanced linting tool. We know that, for example, there's some really interesting work being done in the University of Florida where they are teaching some LLMs about common vulnerabilities using the CVE databases, and are then taking that trained LLM and throwing that at some hardware specs of a hardware block being written, and it comes back and says, oh, this looks like it's found this is reproducing the sort of error that we've seen before. And because in reality, an awful lot of security vulnerabilities, both in hardware and in software, are kind of people, slightly depressingly, making the same mistakes as other people have made in the past. And that's actually what some of the CVEs kind of show, is you see repeated patterns. And AI tooling can actually, the positive side of it is AI tooling can help people find vulnerabilities that, find mistakes that would otherwise have escaped their attention. That's what.
Yeah. And we spoke about realm management and confidential compute. Are these the best ways or the key ways we can protect our AI models from attack or from manipulation, or are there other hardware things we can do to help here?
I mean, it's a great question. I mean, the reality of security is there isn't one silver bullet for all of it. And the famous adage everyone talks about is you're only as secure as the weakest link.
Yeah.
And so the idea that there is only one thing to do, and indeed the idea that security is only one problem, is completely wrong. In fact, in many ways, when you talk about security and I am secure, you should really be saying I am secure against these particular threats.
Yeah.
Be clear about what you're being threat against. Now, what confidential compute and our realm management extensions gives is this ability to be able to allow somebody using confidential compute to use attestation to be told, to be able to certify that they are running on a trustworthy platform. And then the hardware and software is then working together to ensure that even while the data is in use inside our application, inside our AI model, that data in use can't be seen by the main operating system or the main hypervisors, even if they've been compromised. And again, that increases your confidence that if for some reason the platform has been compromised in some way, even if that happens, they can't see your data. It's a trustworthy platform. So that's one very important part of the security story. But there's more to it than that. I talk a lot about memory safety issues. Even governments nowadays actually are talking about memory safety issues, because they have been pervasive for so many years. And ARM has features in its architecture that look for memory safety issues. That's why we've brought in our memory tagging extensions that are now deployed in a lot of our devices. And that effectively is looking for situations where you've got things like a buffer overflow, where essentially by having inappropriate data that goes out of range, you are able to break out of the expected behavior and influence some other part of the data set. And that's then a chink that allows people to break in. So all of these things, again, they've been part of general security. They're not AI specific, but what they do is make the compute that you're running on generally more secure, and therefore make it much harder for people to be able to get in and cause the sort of damage we were talking about before, again, against the AI systems they're running.
Yeah.
And going back a little bit to the realm management extension, something I missed is we've deliberately recognized that it's not just the CPU that has to be protected and run in a realm. We've also got to be able to have accelerators. And this is really important for AI because obviously AI runs on a combination of the CPUs using technologies such as our scalable matrix extensions, but also on GPUs or NPUs or other accelerators. And you want all of that inside your realm, getting that same level of protection that confidential compute gives you. And that's been an important part to the device assignment part of the realm management extensions is an important part of that story, particularly with AI in mind.
Yeah. I mean, we're talking about AI in the cloud there, but when we talk about AI at the edge, usually we associate that with privacy. If the data, especially if it's consumer data, it kind of stays on the device, but it doesn't necessarily mean it's more secure, or does it?
The edge versus the cloud is a really interesting dynamic, and again, you can see both sides of the story. I mean, the positive thing I always like about using some AI at the edge from a security and privacy point of view is that it allows you to contain within a relatively small amount of compute, your critical data, and only let out of the box the stuff that needs to get out of the box. And kind of the principle of least privilege, which is one of the things that security people talk about a lot, is this idea that if, don't give people access to things that they don't need to have is kind of the summary of it. Because yes, you can reason all you like about yes, of course it's secure out there, but if you simply don't make it accessible, you don't even have to have that conversation. And so that principle of least privilege basically says, if I can avoid putting data out from a particular container or compartment, that must be better for security. Really nice example of this, not really associated with things like generative AI, but some of the more sort of image recognition side of it. Really nice example that came across a couple of years ago now is that people want to be able to use technology and sensors and cameras and things for their own personal safety. And we have an aging population, and in a situation where elderly people, my mother-in-law a few years ago, for example, used to fall over a lot, and she didn't live local to us, and so when she fell, we were always worried that how are we going to know that's happened? And a nice example of that is you want to put something like a camera in place to say, well, has she fallen over? Well, a depressing reality there is that actually a lot of elderly people fall over in bathrooms for reasonably obvious reasons that you're going
it's wet.
It's wet, it's slippy, you're bending your body, etc. And the last place on the planet you want to put a camera is a bathroom. So if you can actually put a camera in there, but make sure that no data out of that is leaving that environment, all that is left is the semantic of there is somebody lying down where they shouldn't be. Then again, from a security point of view, well, yes, it's privacy, but it's also security. I mean, they're part and parcel of the same thing. You're not having to trust a huge range of, is the network secure? Is it going on to secure server? All of this information, you can say, well, that is contained principally as privilege in that particular space. So, that is one of a really nice example of why AI at the edge can be a really good thing to do. You don't want absolutely everything going to the data center. Conversely, having AI out at the edge, if you want to put these very high value models onto an edge device. You talk about things that have been perhaps distilled down from the really, really expensive training runs, but are still very high value items if you're a company selling these solutions. Then if you're running in the cloud, you're running it in a relatively constrained data center environment. If you're running at the edge of the network, essentially, if that's a high value model, then the criminals can do all sorts of things because it's in their hands.
Yeah.
You can single step through it in ways. You can try pulling out memory and pushing in memory and so on. And it becomes a great deal more attacks that can be happened when things are out in the field than if they're in well-constrained environments. And this is actually part of the reason why, coming again back to our realm management extensions, we originally thought very much that those were part of a cloud-based solution. But actually, because of this need to protect these very high-value models, we're actually seeing increasing demand for, can you put that confidential compute out at the edge? And for things like people pulling out a memory or maybe a piece of non-volatile memory and putting it back in again and providing a replay attack and things like that, we've been putting in features like our memory encryption contexts, multiple encryption contexts feature in realm management, specifically to increase the resilience against a whole bunch of possible physical attacks. And I think that will be very important for these more exposed places where it's at the edge of the network and therefore potentially easier for malefactors to be able to actually get their hands on it and cause damage. Or black secrets.
Yeah, I mean, we used to kind of speak about confidential compute, where you've got more than one user, I guess, using the same hardware, basically, because it's in the cloud, talking about the hypervisor and so on. But yeah, you're talking about realm management there at the edge. I guess that applies to both. But do all these concepts of confidential compute, are they coming to the edge? Are they already at the edge? Or how should we be thinking about this in terms of the IoT?
They're coming, and certainly there's a piece of work we're doing at the moment, actually looking at an IoT system where we're saying, actually, this really would benefit from having the realm management extensions in it. And that's something that we will be deploying into our cores that are there for running in client devices and on the edge of the networks, as well as where we originally started out thinking about them just in inverted commas in the servers and in the cloud. So no, we're absolutely seeing these technologies being wanted everywhere, primarily, but again, because frankly, everyone wants to use as many security features as they possibly can to try and secure the systems, because coming back to where we started off, the size of the prize is bigger. And the other thing that I didn't actually mention a little bit before is that AI really works well by kind of bringing in lots of different data. And the more of the world that it understands, the more it can use its intelligence to extract something new. And so that's almost runs against this privilege of least privilege that I talked about a little bit earlier, in as much as everything's in the same place. And that makes the target even juicier for the criminals, and therefore makes the security even more important.
Yeah, it's like the metadata that it creates is almost more sensitive than the original data in a lot of cases. So yeah, it's a difficult problem.
There's a huge amount of data there, and the bigger the pools of data, the more attractive they are, and therefore the more they need to be protected. And that's why computer security is such an important part of what we're trying to do going forward.
Absolutely. So confidential compute, I know, was the whole idea is basically to protect data while it's in use or while it's being used. But thinking about protecting data while in use, of course, what popped into my head is fully homomorphic encryption, or FHE, because I've been studying it because it also uses accelerated compute, same as AI does. It's kind of in my beat. So I wanted to ask you whether you think FHE would be complementary here, or how would that fit in with these other security measures that we're talking about?
I mean, FHE is a really interesting and emerging technology. I mean, it's only really been around for the last, people have talked about it theoretically for quite a few years, but it's only really been around for the last decade and a bit. The reality is that what it's doing, for those who haven't fully followed it, is essentially it allows you to do the data operations without having to decrypt the data. So essentially, it finds encryption mechanisms that allows you to provide operations like multiplication and addition without having to decrypt it, and you effectively stay encrypted, and so you're not ever having to access the raw data. The trouble with that is that much as we talk about lots of multiply accumulates as part of kind of the bulk processing, the big matrix multiplies that we do in our in AI processing, the thousands of tops that people now talk about being able to do, those are all mostly multiply adds. But there are also nonlinear operations as you go in that, and those nonlinear operations don't necessarily fit into homomorphic techniques, and there is still a performance overhead playing out, substantial performance overhead compared with what you can do natively. And at the moment, what we're seeing with AI, the reason the AI explosion is happening is because people are providing more and more tops, more and more operations worth of computing, and I'm not sure that people are prepared to take the sort of level of step back in terms of performance to do that morphically. That said, homomorphic, as I said a little bit before, the security of a system is only as secure as the weakest link, and there will be places more on the sort of control plane away from the kind of the bulk processing where you're dealing with the deepest secrets, the most fundamental keys, where things like homomorphic encryption again will be all part of the security story. And this kind of ties into that same thing I talked about before, which is you have to think about all of the different elements of the security. You can't just focus on one part of it, and there are lots of different things that could be attacked, and they get protected in different ways according to the nature of the attacks that are happening against them.
Yeah, I think it's definitely something I'm going to be keeping an eye on. But yeah, very interesting field. Maybe on a slightly brighter note, maybe I can start to talk about how we can use AI to help, how we can use AI to improve security, or how we could potentially start to use AI to improve security. We touched on some of this a little bit earlier when we were talking about the problems that we've got with more AI content everywhere. But what are the main ways do you think that we could use AI to help us in our cat and mouse game?
Well, I mean, again, we touched on some of this, but a lot of it is the fact that AI can essentially analyze what we produce, analyze problems, and if you train AI systems with knowledge of typical vulnerabilities or patterns of problems, then you can use those to provide, as I alluded to before, better linting tools, better checking tools to go and look at things. And so, I think what we'll see with AI is it will be used both on the side of the good and the side of the bad. And that's kind of true of all technologies, that technologies are always somewhat morally neutral. It depends on the human being as to whether they get used well or used badly. And used well, AI can make engineers more productive. It can help them avoid common pitfalls. It can help analyze situations and say, look, there is a potential security issue there. It can write better code in some circumstances. Used badly or used by an adversary, then it can be used against you. So it plays to both sides of the coin, but it's an extremely, what we're going to get is more productivity from engineers and creating more stuff. And I think you're going to see people, producing more and more tooling to help with security based on it. And we know for a fact a lot of people like the virus scanners. This isn't my area, but you go to any security conference and you'll see lots of people selling virus scanners and other things, and all of those trumpet their AI credentials left, right, and center.
Yeah.
In terms of finding patterns of use. I mean, one of the things that we've done a little bit of research on is, can you at the hardware level start spotting abnormal behaviors in the CPU that might be indicative of an attack. And then the question is, could you embody something in the hardware on that element? Well, that's still very much in the kind of research phase. But AI gives and it takes away, and these things, as do all technology.
Yeah, with AI, if AI is both the cat and the mouse in the game, do humans always? Yeah, do humans always have to be smarter than the AI to make sure security doesn't become a problem? Otherwise, AI is just playing against itself. Like we have to stay one step ahead, right?
Well, I think we have to. I mean, this is the general the message that everybody is giving about AI, and this is not just about security. This is a revolution, and all technology revolutions, people have to learn how to use the technology well to get the best out of it. And the machines have always ended up doing certain things better than humans. I mean, back in the days of weaving carpets or whatever, the spinning jenny did a better job than humans of creating weaving, in the same way as computers do a better job of adding up numbers than I do, and AI will do better things. But human beings always find that they can step up and keep that overall picture of the overall strategy while using the AI as a tool. And I think that's going to be just part of the AI revolution, in the same way as all technological revolutions have played out.
Thank you so much, Richard. So much food for thought there. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by AspenCore Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.